Okay, good morning, everyone, and good afternoon to our European colleagues. My name is Betty Wells, and I'm the VP of Marketing for Envirogen Technologies. I want to thank everyone for joining Envirogen's webinar today on understanding and operating ion exchange systems. Our speaker today will be Katie Biley. Katie is our Business Development Manager based in our Memphis, Tennessee IX Regeneration facility, and her focus is primarily on ion exchange systems, resins, and regeneration. I trust you will find today's presentation informative. Katie?
Thank you, Betty, and thank you everyone for joining. This presentation is going to be in a listen-only mode, so if you have questions during the presentation, please just put them in the chat and we'll answer them at the end. The topics we'll be covering today include understanding IX systems and resin, regenerating IX resins, off-site versus on-site regeneration, operations and maintenance, new system design criteria, and Envirogen's IX capabilities. We're going to begin by covering some of the basics on ion exchange resins and systems. Excuse me. Ion exchange and DMN systems basically remove dissolved ions or electrically charged molecules. If these ions carry a positive charge, they are called cations, and those with a negative charge are called anions. IX systems can be targeted to remove specific ions like nitrate, arsenic, organics, metals, as well as other radioactive ions. There's a wide range of areas where IX is used in industrial feed water, processed water, wastewater, and groundwater remediation to remove the various ions as discussed on the previous slides. As can be seen on this slide, IX can be used in numerous ways depending on the desired contaminants to be removed. While most of the applications call for removal of the offending contaminants, in other cases the goal is recovery. An example would be recovery of expensive catalysts for reuse. So how exactly does IX work? Ions, when dissolved, form charged species positively or negatively. The IX process is an electrostatic one where the targeted ions replace ions that are associated with the fixed functional sites attached to the resin beads. This process is a reversible one. The resins themselves are cross-linked polymers, most commonly polystyrene, with functional groups attached. The functional groups are charged either positive or negative and attract ions of the opposite charge. Basically, as water flows through the resin, the problematic ions displace the ions that were electrically bound to the fixed charge of the bead. Hence, there is an exchange of ions. There is an order of selection called affinity for each ion as it is associated with the functional site of the resin. For example, calcium has a higher affinity than sodium for a strong acid cation resin. The most well-known IX process is water softening. Here, the offending contaminants are calcium and magnesium minerals, which are positively charged ions. The resin used to remove them contains sulfite, sulfur trioxide functional groups, which release the less attractive sodium ions it was attached to in favor of the calcium and magnesium ions, therefore removing them from the water. Once the resin is exhausted, the process can be reversed via regeneration. In this case of softening, a concentrated sodium chloride brine is used to release the captured ions and restore the functional groups to their original state. There are three main types of resin used: cation, which are positively charged, anion, which are negatively charged, and mixed beds that have a combination of cation and anion resins mixed together. In addition to the main resin categories, there are subcategories. Cation resins, for instance, come in strong acid type and weak acid type. Each resin type performs a different function and is used for specific purposes. For example, a strong acid cation resin would be selected for full demineralization, but a weak acid cation resin would be used for dealkalization or softening of hardness associated with alkalinity, bicarbonate ion. Let's take a look next at how ion exchange resins can be regenerated. In most cases, the ion exchange resins can be regenerated once their capacity is exhausted. The regeneration process typically involves the use of acids or caustics. This process can be carried out on the customer site, or the resins can be sent to an off-site regeneration facility. Many customers do prefer an off-site since they do not have to store, handle, and train operators on safe use. With some contaminants, such as perchlorate, it is best to simply dispose of the spent resin. When regenerating resins, there are two different methods: co-flow, which is most common, and counterflow, which is used for high purity applications. We will explain more. As shown in this illustration, as the resin is exhausted, it has various contaminant ions attached to it. The service flow in this example is from the top to the bottom. When regeneration is initiated, regenerant solution is flowed through the resin bed. In this case, co-flow, the regenerant flows in the same direction as the service flow from top to bottom. The most thorough regeneration occurs in the zones first contacted by fresh regenerant. The result is that the bottommost resin may still have some contamination and may not be 100% regenerated. Consequently, these systems have a higher leakage rate of the contaminant ions than the counterflow alternatives. Now let's look at the alternative method of counterflow. Here the regenerant flows in the opposite direction of the service flow, or from bottom to top. In this case, the resin at the bottom of the tank sees the clean regenerant solution and is fully regenerated, while the top of the bed may still have some contaminants present. So why does this matter? If you have a high purity application, you want low leakage of contaminants into your downstream DI water. In the counterflow method, the bottom of the resin bed is fully regenerated and able to produce the highest purity water. For comparison purposes, where absolute pure water has a resistivity of 18.2 megaohm, only counterflow regenerated mixed bed systems can offer the lowest leakage rates to deliver ultra high purity water of 17 plus megaohm resistivity. A good two-bed countercurrent regenerated system can produce 15 plus megaohm resistivity, while a two-bed co-flow system would only produce a 10 plus megaohm resistivity. So now let's consider if off-site or on-site regeneration is best for your plant. On-site regeneration does involve the storage and handling of strong acids and caustics. It is important that operations be properly trained in handling these chemicals. You will also need to monitor the system to identify when the resin is approaching exhaustion and should be regenerated. Some customers will do this on a set schedule to minimize the possibility of a contaminant breakthrough. The actual regeneration process can be controlled with the PLC that manages the initial backwash, regenerant flow, and rinse cycle. In situ mixed beds are a bit more complex to regenerate, as the resins must first be separated through the backwash cycle. The mixed bed system must also have separate chemical headers to accommodate different regenerants. In addition, the resin volume must be maintained with a narrow range for proper regeneration and to prevent contact of the resin with the wrong regeneration solution. With off-site regeneration, customers will send their tanks or super sacks of resin to a third party to regenerate the resin for them. Envirogen offers this service in our Memphis, Tennessee facility. There we will segregate each customer's resin and never intermingle with other resin. If you're operating a high purity system, we are fully equipped to handle mixed beds and rinse with high purity water. Our facility can also handle metal-laden resins used in wastewater applications and has the necessary discharge permits to safely discharge the waste. I mentioned our ability to handle high purity resin. Our DI water plant produces the critical quality level to rinse the resins for return use in your high purity process. Now that we've covered the resins and regeneration of resins, let's look at operational and maintenance issues with IX systems. You may start seeing symptoms that indicate you're having operational issues. For example, the quality of the effluent may decline, resin may require more frequent regenerations, or you may be using more regenerate than previously. Resin fouling is one of the most common types of issues in IX systems. So what are the different types of resin foulants? There are many, and what you experience will depend on the feed water composition and types of regenerants used. Iron, hardness, calcium sulfate, oil, and silica are just a few. Many of these are reversible, especially when caught early. Others, such as barium sulfate, participates and clogs the resin bed. Some may permanently adhere to the resin, causing a complete replacement of the resin. The resins can also suffer from degradation. Resins degraded by oxidants, heat, or organic materials will often need to be replaced. If recognized early, changes can be made to prevent further degradation. The real goal is to prevent it from occurring by eliminating the source of the problem. In some cases, you may need lab analysis to determine if the resin is fouled or degraded and to identify the cause so it can be corrected. Envirogen offers this analytical service in our Memphis facility. IX systems can also suffer from mechanical failure, such as leaky valves, as well as damaged distributors or screening. Instrumentation problems can also falsely indicate a problem where none exists. Proper system operation and maintenance should prevent or minimize these occurrences. In general, IX systems require regular service to keep them running at peak efficiency and to prevent costly problems. Regular inspections and calibrations, as well as a review of operational data, should be performed on a frequent basis of monthly or quarterly. Additional services should be performed on an annual or as-needed basis. At some point, the media will need to be replaced, along with other wearable parts such as gauges, flow meters, and sensors. Envirogen can perform all of these services on a contractual or as-needed basis. Perhaps you have an older system and are looking to install a new ion exchange system. Where do you even start? Well, the first step is to provide all the process parameters, such as flow rates, feed water constituents, and desired treatment level. In addition, you will need to identify what contaminants you want to remove, what volume of treated water is required, if the plant runs continuously or intermittently, and is space available to install the system. Other challenges to consider are around personnel, finances, technical support, and understanding local regulations for discharge. One question that will impact the system design is the choice of on-site or off-site regeneration. You should carefully consider the pros and cons of each that were presented earlier, especially if your willingness is to store and handle acids and caustic chemicals. Finally, you should consider if you will service and maintain the system in-house or prefer to hire a service provider such as Envirogen. If this is a brand new installation, it is highly advised to conduct lab and/or pilot testing before moving forward. During this testing, the optimum media choice can be identified, removal expectations can be set, and the regeneration method determined. Envirogen has a lab and pilot capabilities in our Memphis facility. Envirogen would welcome the opportunity to discuss any new IX system needs you may have. We offer a range of proprietary ion exchange systems to serve any area of your site. Our experts have over 30 years of experience designing and operating ion exchange systems for hundreds of sites. Because we often operate the system we design, you can trust that they are well designed to perform efficiently and effectively over the long term. Our single and multi-bed designs accommodate any possible flow rate, and redundancy allows for uninterrupted operation. We will help you choose the best resin type for your application and can source from all leading resin manufacturers. This chart depicts the full range of IX products we offer, including on-site and off-site regenerable co- and counterflow regenerations for flow rates from 5 up to thousands GPM. Let us know how we can assist you with your next project. And that concludes today's webinar. I would like to thank all of you for attending, and now we can address any questions that you may have. If anybody has questions, please submit them in the chat feature. Following questions, if anyone would like to stay on and hear more details about our system designs, Rob Loken can walk you through the system details and present photo galleries of some of our successful installations. Are there any questions? See, Jill asked if we could get a copy of the presentation. Yes, you can. We'll send that out to everyone.
So what will happen is after the meeting ends, everyone will get an email with a thank you for attending, and there'll be a link to the recording of the presentation. So you'll be able to view the recorded presentation with Katie's voice over on your own or share it with your colleagues.
It doesn't look like we have any additional questions. So Rob, why don't you go ahead and run through the photo galleries and the system details, and those who want to stay on are welcome to.
Envirogen has several standardized ion exchange system configurations that we have put together for various applications. The highest efficiency system is called the SIMPAC system, standing for Simulated Moving Packed Bed Design, in which there are N equals the number of vessels needed for the flow rate, and then there will be 3 vessels in a regeneration configuration. That regeneration configuration allows the reuse of the chemicals, increasing the capacity per regeneration, and also the reuse of the rinse water. Consequently, it has the lowest waste rate of any process. Typically, this is used in applications targeting a specific contaminant, such as chrome or nitrates or something along those lines. It can also be used in a DMIN type application. So as I was saying, here's a couple examples of some nitrate treatment systems that are out in California in particular. It also is used for arsenic and softening, and it can be used in a DMIN in which one train will be cation, the other train will be anion. A variation of this and a less expensive version of the Simpex system is a Minex. The Minex system is designed to have n number of vessels for the service flow, but it's also to recapture the regenerant as it's used in the process, and use that again to increase the capacity associated with the system. This type of design, it can be with fiberglass vessels, or it can be with carbon steel lined vessels. It all depends on the plant requirements and the client's request for vessel design. Next. So as Katie referred to, you can have off-site regenerable systems. We have several designs associated with these types of systems, in which in a FlexSorb process, the bottles are exchanged with the to the site. And in that particular case, they can be as small as 3 cubic feet per vessel, and all the way up to 36-inch diameter or even larger ion exchange tanks, in which the tanks are moved. The Hypersorb system, which is also going to be presented here, is for the higher flows, and the resin is actually moved back and forth. So as we discussed, there's various configurations of the FlexSorb system. We use 14 or 16-inch diameter vessels typically, and the standard package is from 5 to 200 GPM. The Hypersorb system, as I described earlier, is when the resin is transferred to a transportation vessel, or it is put into super sacks so that it can be regenerated off-site. We have various designs and system configurations up to 63-inch diameter tanks for this type of service. So let's look at a few pictures. A lot of our systems have gone into containerized systems, so they can go into buildings or in containers, depending on the weather and the configuration required for a given site. So here's a couple examples of nitrate systems. Next. We also do radiological treatment, several uranium removal systems, in which we actually do the service and operations of those particular sites, and have a radiological safety officer associated with those particular sites. Those are a once through disposable application. We also do perchlorate or perchlorate and nitrate treatment, depending on what is in the well water. Perchlorate has become a major issue, so has PFAS. And all of those, they can be regenerated, but the most economical process is typically using it in a disposable method, in which the resin is thrown away after absorption. It's usually incinerated. Are there any questions out there? You are free to contact us, contact Katie, and or the information at Envirogen.com, and we'll be glad to assist you in your questions, applications, and process design. We also do process development, and product purification for various clients. Thank you.
Thank you, everyone, for attending today.